Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer the next 10 questions from SSR chapter Equilibriums. Previously, I answered first 30 questions. In this video lecture, I am going to answer the next 10 questions, question 31 to question 40. So let's start. First question. The accuracy of SSR height as displayed to ATC is going to be what? So I have explained this before, I will do it again. So let's say this is your standard pressure setting datum 1013. There is aircraft flying at a vertical distance from 1013 datum, and the pressure altitude is 18,500 and let's say 70. Now this 18,570 is the accurate value at which your aircraft is flying. Now the mode C capability of your transponder, in your transponder will transmit this altitude information to ATC as 18,600. So 18,570 will be reported as 18,600. Let's say pressure altitude information is 18,520. So in that case, the mode C capability in your transponder will transmit information, altitude information as 18,500 feet. So instead of transmitting accurate information of 18,520, it will automatically transmit 18,500. Instead of transmitting 18,570, it automatically transmits 18,600. This means, what do we learn from this? All altitudes are reported in 100 feet increments. Okay, reported in 100 feet increments, 500, 600. And this reports are accurate within plus minus 50 feet. Okay, remember this. So the difference between 18,570 and 18,600 is 30 feet. The difference between 18,520 and 18,500 is 20 feet. So remember, the figures are rounded up to the nearest whole number. Okay, so the correct answer here will be accuracy is plus minus 50 feet. Next, why do clouds not appear on the secondary radar screens? That is because the transmission signals and reception signals are on different frequencies. Now in case of primary radar, that is airborne weather radar is an example of primary radar. So in that case, your aircraft will transmit a radar frequency, a radar pulse at a particular frequency. In case of airborne weather radar, that is 9.375 gigahertz. 9.375 gigahertz. Now this frequency will have a corresponding wavelength of 3.2 centimeter. So when this radar pulse goes to the target, it will strike the target and get reflected back at the receiver, airborne weather radar receiver. Okay, so this is the advantage of primary radar. Primary radar operates on one single frequency throughout its operation. So the transmission frequency will be equal to the reception frequency. But in case of secondary radar, what do we observe? In case of secondary radar, in case of secondary radar, the ground will transmit at a particular frequency the interrogation pulse. In case of secondary radar, the interrogation pulse from a ground station, from a ground interrogator will be equal to, that will be equal to 1030 megahertz. And the transponded or the reply pulse coming from aircraft to the ground interrogator, we call it reply pulse, that will be at a different frequency of 1090 megahertz, right? So transmission frequency is 1030, the reception frequency is 1090. Both are different. So since this frequencies, secondary surveillance radar operates on two different frequencies, that means it does not rely on echo principle. What is echo principle? Echo principle is used by primary radar. The radio wave will go to the target, it will get reflected from it, it will get echoed. But in case of secondary radar, echo doesn't happen. What happens is when this interrogation pulse goes to aircraft, the aircraft will reply to it, to this interrogation pulse uniquely. It will send its own energy. Okay, so echo is not happening, it is sending its own energy in the direction of the interrogator, and therefore there will be no interference of any other cloud, any other large water droplet which is going to fall between, the interrogator and your aircraft. Let's say there is a cloud here and it has many water droplets in it. So the reflections from these water droplets will not interfere with secondary radar operation, because secondary radar uses or utilizes two different frequencies, not the same frequency of transmission and reflection. So remember that. So the transmission and reception signals are on different frequencies. 33. SSR is not affected by weather clutter because it uses different frequencies for transmission and reception. Same question. 34. What most affects the range available from secondary surveillance radar? So secondary surveillance radar works in the frequency band of UHF. UHF means it depends on line of sight range. Line of sight range. That means aircraft must be in the line of sight in order to receive the interrogation pulses, right? The formula for line of sight is 1.25 H1 height of aircraft from mean sea level, H2 height of ground interrogator from sea level. Now this can also be simplified into another formula called 12 root F, where F stands for flight level of aircraft. The flight level of ground station is considered 0 because ground station or interrogator is considered to be at sea level, ISA sea level. So 12 root flight level is another simple formula which will simplify your calculation. F stands for your flight level of aircraft. Okay, so line of sight is what it depends on. The spacing between two pulses transmitted by SSR interrogator decides what mode is used. Okay, decides what mode is used. Now in case of mode A, the spacing between first two pulse, okay, is 8 microseconds. And in case of mode C, okay, in case of mode C, the interval between the pulses is going to be, if I am not mistaken, it is going to be 21 microseconds. Okay, so there are three pulses, pulse 1, pulse 2, and then a pulse 3. Pulse 1, pulse 2, and pulse 3. Now the difference between pulse number 1 and pulse number 2 is fixed. and that is 2 microseconds for mode A as well as for mode C. For mode C, I will draw another diagram. Pulse 1, pulse 2, and then pulse 3. So pulse 1, pulse 2, and pulse 3. So the difference between pulse 1 and pulse 2 is 2 microseconds for both modes A and C. And pulse 1 and pulse 3 will be 8 microsecond for mode A, and pulse 1 and pulse 3 will be 21 microseconds for mode C. Okay, so that's why the spacing between two pulses will determine what mode you are using, mode A or mode C. Question 36. With regard to SSR, secondary surveillance radar. Secondary surveillance radar. The interrogator is on the ground and transponder is on the ground. Wrong. Interrogator in the ground, transponder in aircraft. Yes. Okay. So in case of secondary surveillance radar, okay, surveillance radar, monitoring radar. So the radar or the transmitter or interrogator will be on the ground. It will send interrogation pulses to aircraft in the atmosphere. The aircraft will transpond or respond to those interrogation pulses by sending a transponding signal, a reply pulses. In case of DME, you have transponder on the ground and interrogator in aircraft. Ulta. So SSR, we have interrogator on the ground and transponder in aircraft. Question 37. Why is the effect of returns from storms not a problem with SSR? Again, a similar question, because SSR does not use the echo principle. Like primary radar, it doesn't use the echo principle, it uses two different frequencies. So option Charlie is the correct option. SSR in ATC use is complementary to primary radar. Now air traffic controller will make use of both primary radar and secondary radar. Primary surveillance radar will give accurate range and bearing information of aircraft. Secondary surveillance radar will give accurate information about your flight ID, altitude, mode C capability, etc. Okay, so both the advantages of both the systems are combined in order to enhance safety. 39. When both SSR and primary radar is represented on the display, altitude information is presented for all targets? No. Altitude information will be presented for those targets that have mode C capability in their transponders. Maybe all targets do not have mode C capability. Okay. The SSR information is more accurate in bearing and distance. Wrong. The primary radar is accurate in bearing and distance. Yes. Primary radar information is superfluous. Wrong. With SSR, interrogation and response signals are standard separated by 60 megahertz. So standard frequencies for ground interrogator, the standard frequency is 1030 megahertz. For aircraft transponder, the standard frequency is 1090 megahertz. So these are standard frequencies meant for ground and aircraft, whether they are transmitting or interrogating or replying. And you can see the difference between these two frequencies is 60. The standard frequency is separated by 60 megahertz. So this concludes our lecture. I hope you have understood all the 10 questions. Simple questions. Read the chapter and solve as many questions as possible with me. So more you solve, the more practice, more solving questions, more confidence you will get, more conceptual clarity you will obtain. All the best. Share this video with your friends, please, and like this video lecture. Don't miss my next video lecture.